Hey, and welcome to The Explainer. You might not realize it, but right now, all around you, there's an invisible war being fought. Today, we're going to crack open the high-tech toolkit that humanity uses to control this microscopic world of bacteria, viruses, and fungi. So let's just dive right in. I mean, it's a really good question, isn't it? In our labs, in hospitals, even in our own kitchens, we're constantly trying to manage these tiny, tiny organisms. The methods we use are incredibly powerful, super precise, and you know what? They're absolutely essential for modern life. So how exactly do we pull it off? Okay, so before you can even think about going on the attack, you have to set up your defenses. And the first rule in microbiology isn't about destroying microbes, it's about controlling them. This whole foundational concept has a name: biosafety.
Think of it this way. Biosafety is all about containment. It's the set of rules and the physical barriers we create to keep potentially dangerous microbes exactly where we want them. It's about making sure they can't harm us or escape out into the environment. It's job number one. And this is what biosafety looks like in the real world. These are the day-to-day rules for the pros. Wearing PPE like gloves and lab coats, using these special ventilated cabinets to work in, and of course, getting rid of waste safely. It really all boils down to looking at the risk and then taking the right precautions.
So, once we've got the safety part down, then we can start talking about elimination. But we have to be really precise with our words here. See, sterilization and disinfection, they are not the same thing. Disinfection is about knocking down the number of harmful microbes, kind of like thinning the herd. But sterilization? Oh, that is total annihilation. It is the process of destroying all forms of microbial life, and that includes the super tough ones called spores.
All right, let's get into the toolkit. Our first and, honestly, most powerful tool is also one of the oldest and most reliable: just plain old heat. It's an incredibly effective way to get to that true sterilization we were just talking about.
So how does it actually work? Well, moist heat, like steam, basically cooks the microbes from the inside out. It causes all their essential proteins to just clump together and completely lose their shape. That process is called denaturation. The absolute best analogy is scrambling an egg. Once you've scrambled it, there is no going back. That cell is completely and totally dead.
But, not all heat is created equal. Boiling water at 100 degrees Celsius, that's great for making water safe to drink, but it will not kill those tough bacterial spores. Pasteurization uses even lower heat, which is perfect for protecting the flavor of things like milk. But the real gold standard is the autoclave. By using steam under intense pressure, it gets up to 121 degrees Celsius and just destroys everything, spores included. And that is why it's non-negotiable for sterilizing things like surgical tools.
Of course, you can't use steam on everything. I mean, think about it. For materials that steam just can't get into, like glassware or powders or oils, we have to turn to dry heat. It works in a completely different way, more like dehydration and oxidation. Now, this takes much higher temperatures and a lot more time, but it's the absolute perfect tool for certain jobs.
Okay, but what about all the stuff that can't handle the heat at all? Things like plastics or very sensitive medicines. For that, we have to look beyond temperature. We need to explore some other really powerful tools in our kit.
Our next tool sounds like it's straight out of science fiction: radiation. This is a really high-tech method that sterilizes things by attacking the very core of a microbe, its DNA. It's basically shredding the genetic instruction manual for life.
And there are basically two main flavors of it. You've got ionizing radiation, like gamma rays. This stuff is incredibly powerful. It can shoot right through packaging to sterilize things like plastic syringes and catheters. Then you have non-ionizing radiation, which is mostly UV light. Think of this one as more of a surface cleaner. It doesn't penetrate well at all, but it is fantastic for zapping microbes in the air, in water, or on the surfaces of lab benches.
Yeah, so the appeal of UV light is pretty obvious. It's simple, it's cheap, and it kills all sorts of stuff without any heat. But, and this is a big but, its major weakness is that it can't get through things. It can only kill what it can directly shine on. It's also really harmful to us, which is why you should never, ever look directly at a UV light source.
Okay, so our next method doesn't actually kill anything at all. Instead, it works more like a bouncer at a club, physically removing the microbes from a liquid or from the air. This method is called filtration.
The principle here is just brilliantly simple and effective. You pass a fluid through a filter that has microscopic pores that are way too small for bacteria or other microbes to squeeze through, so the liquid comes out the other side perfectly sterile and all the bad guys are left trapped on the filter. This is the go-to method for heat-sensitive liquids like vaccines, antibiotics, and IV fluids.
And that brings us to our final and by far our largest and most diverse set of tools: chemicals. We use these for pretty much everything, from wiping down a kitchen counter to sterilizing very sensitive surgical equipment. So the big advantage of chemicals is that they're often fast, cheap, and really easy to get your hands on. The downside? Well, they can be toxic to us, and there's absolutely no single chemical that works as a perfect solution for every single situation. So choosing the right one is, well, it's critical. And that right there brings us to the most important lesson of this entire explainer. Sterilization isn't about having one perfect tool. It's about having a whole toolkit and knowing exactly which one to pull out for the job at hand. This is where it all comes together. Got a heat-resistant steel scalpel? You autoclave it. A plastic syringe that would just turn into a puddle of goo? You zap it with radiation. A delicate heat-sensitive vaccine? You filter it. A lab surface that needs a quick clean? You shine some UV light on it. You see? It's all about matching the method to the mission.
And just to give you a sense of the scale here, especially with the chemicals, we are not talking about a handful of options. There are literally thousands of different chemical agents being used right now in our homes, in labs, and in hospitals. This just makes choosing the right one a super critical decision that professionals have to make every single day.
So when it all comes down to it, there really is no single best way to sterilize something. The real key to controlling this invisible world is understanding the material you're working with, the risk you're actually facing, and the unique strengths and weaknesses of every single tool in your toolkit.
This knowledge, this toolkit, has fundamentally changed everything, from medicine to food safety to science, and it's made our world immeasurably safer. It really makes you wonder, as these microbes continue to evolve, what new challenges are coming our way, and what new tools are we going to have to invent to face them. Thanks for joining us on The Explainer. We'll see you next time.